Hello everyone. In previous class, we knew about global sequence alignment. Today we will know how global sequence alignment is done with a proper example. In global sequence alignment, we talk about the Needleman and Wunsch algorithm. Needleman and Wunsch algorithm use scoring schemes. Here we take +1 for every match, -1 for mismatch, and -10 for gap penalty. In Needleman and Wunsch algorithm consists of three steps. First, create 2D matrix. Number 2, trace back. And number 3, final alignment. A matrix indexed by residues of each sequence is built recursively such that d of ij equal to max of d of I minus 1, j minus 1 plus sequence cell box xi, yi or d of I minus 1, j plus gap penalty or di, j minus 1 plus gap penalty. It means we will take three values after calculation from the diagonal, up and side value. Subject to boundary condition, S of I, j is the substitute score of residue I and j, and G is the gap penalty. So in this we can see here we have to calculate three values from side, diagonally and from up. Consider the simple example. First, the alignment of two sequence is send and AND, which is pronounced as SEND and AND. Find the best alignment between two sequences using Needleman and Wunsch algorithm. The cells of score matrix are labeled as C of I, j, where I equal to 1, 2, n and j equal to 1, 2, n. Here we can say the cell between where C of 1, 1 to C, 4, 5 by calculating AC and D and A and D. Now, the first row and the first column of score matrix and traceback matrices are filled during the initialization. Here in initialization, we can find the first cell value will be 0 and here the gap value will be for the side. We'll add the -10. 0 plus -10 equal to -10. Here in the for this cell, previous cell value -10 plus gap value -10 equal to -20. For this cell, previous cell value equal to -20 plus gap value -10 equal to -30, and for similar for the last cell. Here also the same equation. The first value is the 0 and second value will be previous cell value 0 plus gap value -10 equal to -10. Here for this cell, here for this cell we can find previous cell value -10 by plus gap value -10 equal to -20. For this cell, previous cell value equal to -20 and plus gap value plus -10 equal to -30. Here the arrow will be from the left, 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 and here the arrow will be up, 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 as we can find the value from the upper cells. The score matrix cells are filled by row starting from the C2, 2, where we will find the T consequent values and find out the maximum value and put it in the cell. The score of any cell I, j is maximum of Q of diagonal equal to C of I minus 1, j minus 1 plus we will check about match or mismatch value. Q up equal to C I, minus, j plus gap value and Q left equal to C I, j minus 1 plus gap value. Here we will find the three cells diagonal, up and side value, and which one is the maximum. We will put the value in the calculative cell. Here from this example we can find, where we can see the question mark, what will be the value. Here we will calculate for the C2, 2. For diagonal, we can find the value of cell 1, 1 plus either its match or mismatch. Here, if we take the previous slide, we can find that here the previous cell C, C C equal 1, 1 equal to 0, and we either match or mismatch. Here we can find it doesn't match, so it will be -1. Here the value is a bit uh, a bit mistaken. Here it will be -1 and the value will be -1. Here it will be corrected. And Q up equal to, we can find C1, 1 plus gap value, and here we can find that the value is of C of 1, 2 equal to -10, and gap value is -10, and the value is -20 and -20, so the value will be -1 as it is the maximum. Here the calculation is a bit mistaken and it will be -1, and here all calculations has been done, and we'll get the matrices with the value and with the arrow directions. The traceback equal to the process of deduction of the base alignment from the traceback matrix. The traceback always begins with the last cell to be filled with score, the bottom right cell. One moves according to the traceback value written in the cell. There are three possible moves: diagonally, towards top left corner, and the matrix, up or left. The traceback is completed when the first and top left cell of the matrix is reached. That means done cell. Here, if we find out the diagonal, we can find out the arrow cell. Here the diagonal, and we will making the arrow from the arrow what is the done, and we will alignment depending on these arrows. The first cell from the traceback path is diagonal, imply that the corresponding letters are aligned. So we'll align from the last alphabet, which is D and D. The second cell from the traceback path is also diagonal, imply that the corresponding letters are aligned. So it will be N and N. The third cell from the traceback path is left, imply the gap in the left sequences. We stay on the letter A from the left sequences, which will in the upper sequence it will be E, and in the lower sequence it will be gap. The fourth cell from the traceback path is also diagonal, imply that the corresponding letters are aligned. We consider the letter A again. This time it is aligned with S and A. Compared with exhaustive search, the best alignment via Needleman and Wunsch algorithm, we find out the alignment, which one is this, and the exhaustive search, where we can find many types of alignment, where the gap can be in front, in middle, in third position, and in the last position, and we calculated the scores, where we can find the +3, which one is the best score. In summary, we can say that the alignment is covered the entire length of two sequences. The traceback starts from the lower right corner of the traceback matrices and completes in the upper left cell of the matrix. The Needleman-Wunsch algorithm works in the same way regardless of the length of complexity of sequences and guarantees to find the best alignment. The Needleman-Wunsch algorithm is appropriate for finding the best alignment of two sequences which are I of the similar length, and number 2 is similar across their entire length. As considered long sequences, the situations quickly turns against the exhaustive search. Two 12 residue sequences would require considering 1 million alignments, and 150 residue sequences would require considering 10 to the power 88 alignments, which is approximately 10 to the power 78 is the estimate number of atoms in the universe. So where we can you can also find that 150 residue sequences, the Needleman-Wunsch algorithm requires filling 150 by 150 matrices. I hope you understand why global alignment is important and what is the problem of global alignment.